So this problem is asking you to show if f of x and g of x are inverse functions. And I'm going to do this two ways. I'm first going to find it myself, and the other way is I'm going to compose the two functions, which is probably the way that you guys would normally do it. You just compose the functions. But I'm going to show you guys both ways because it's extremely valuable. So we're going to work with this guy, and we're going to try to make him into that guy. And to do that, this is one strategy. You can say, this is y, and we're going to switch the x's and the y's. Okay, so we have x equals y plus 3 over y minus 3. You don't have to do it this way. I just like doing it this way because you guys are used to getting y alone, and so I wanted to make it look like that. We're trying to get y alone. So to get y alone here, I'm first going to get rid of this fraction. This fraction looks kind of nasty. So what we're going to do is we're going to multiply both sides by y minus 2. When I do that on the left side, I get y times x minus 2 times x. And then on the right side, it's good news. These just cancel out. And so you have y plus 3. Remember, our goal is to try to get the y alone. And we have a problem right now. We have a y term over here and a y term over here. So this is our strategy. As soon as I see this, I am reminded of what I want to do to try to get the y term alone. And that is first, get all the y terms on the same side. So I'm going to subtract y from both sides. And at the same time, I'm going to add 2x to both sides. So now I have yx minus y equals 3 plus 2x. So I want to get rid of this y, and I cannot add these together. So what we're going to do is we're going to factor out a y. It's kind of like the greatest common factor thing that you guys usually do or have done before. So I'm going to take a y out of these. So if I divide this by y, that's going to be x. If I divide this by y, that would be 1. Then I have 3 plus 2x. Okay, now you can probably see it. What's the last thing I would have to do to get the y alone? Divide by x minus 1. So I get y equals 3 plus 2x divided by x minus 1. Which, isn't that the same thing as this? They're the same. I mean, we'd have to switch the order of these, but that's no big deal because addition is commutative. And so, yay, it works. The other way to check if two functions are inverse functions is to plug them into each other. And you can do it whichever way. You can plug the f function into the g or the g function into the f. So I'm going to do f o g, which is the same as me saying this, f parenthesis g parenthesis x parenthesis parenthesis. And some of you guys are like, well, what's the freaking point of this? I can just write this. You're right. That's something frustrated with me as well. But I just know that probably in higher levels of mathematics, like linear algebra or something like that, writing it like this has some benefit. So they're probably just trying to get you used to writing it like that. But this is what we're essentially doing. Okay? Okay. So I'm taking f and I'm plugging in g. And what is g? It's 2x plus 3 over x minus 1. So what does that look like? Whoops, my parenthesis there. All right. What does that look like? Well, I'm taking this, I'm plugging it into this. Oh, man, that looks dirty. Look at all that stuff. All right, so we're going to go 2x plus 3 divided by x minus 1 plus 3. Then our denominator, we have 2x plus 3 divided by x minus 1. And then we have our function there. So we have to simplify this dude. Our end game is that this would simplify to just x. If this simplifies to just x, then we know that g and f are actually inverse functions of each other. So let's get busy. On the numerator, I need to find common denominators so I can add those together. On the denominator, same thing. So on the numerator, let's see what it looks like. I wonder if I could fit that all right there. Nah, probably not. So I get 2x, let's write it over here, 2x plus 3 over x minus 1. And then on the 3, I'm going to multiply the top and the bottom by x minus 1. Okay, so then I get 3x minus 3, over x minus 1. So now my denominators are the same on top. I'm going to do the same on the bottom. I have 2x plus 3 divided by x minus 1. There's probably another way to do this, but Anyways, we'll just continue on here. So I'm going to multiply the top and bottom by x minus 1. And then I get negative, so let's still go plus, negative 2x plus 2 divided by x minus 1. Make sure you don't lose your negatives on that one, guys. That's an easy mistake to make. And now on the top, I can, oh man, look at that. Actually, you know what I think I want to do? I want to take the numerator and the denominator and multiply the numerator and denominator of this gigantic fraction by x minus 1. You guys see what will happen if I do that? It'll kill all my fractions, and I'll be just a little bit happier. Distribute this, and that goes that. And then I distribute this to each of these, and those will go away. Oh, it's beautiful. It's so beautiful. Okay, we'll keep going. On the top, we have 2x plus 3. Then we have a plus 3x minus 3. On the bottom, what we got 2x plus 3 minus 2x plus 2. Oh, man, I'm hoping this simplifies down to what we want it to be. Let's go on a rampage right here. All right, on the top, what am I left with? 5x. Okay, on the bottom, what happens? What do I get? This 2 cancels out with that 2. No, it doesn't cancel out. Look, it's 2x. Come on, guys, pay attention. All right, and then we had, so that 2 and that 3 add together. Oh, this 2x cancels out with that 2x. Oh, there we go. So we get 5 on the denominator. What does that equal? X. Equals 1x, because 5 divided by 5 is 1x. And so, are they inverses of each other? For sure. You done.